Hey folks, welcome to this session about service meshes. Because I'll be on holiday by the time the conference takes place, it's gonna be recorded, but I'm not gonna do any video editing. Maybe just assemble some demos, but it's gonna be like if it would be in a live, let's say, session. So today's topic is why are service meshes on the verge of becoming the new norm, right? So before diving to the topic, I will quickly introduce myself, or first thank the sponsor for the coach for helping organize the coach and of course coach and conference. So I'm basically Stefan Aiskens. I'm an Azure MVP. So feel free to follow me on Twitter, and of course you can always have a look at my GitHub repos where I have a few stuff available. So I basically recently wrote two books on, let's say, one on Azure, and another one on software architecture. But basically, both books also talk a little bit about service meshes, especially the Azure book. And today I'm going to use basically AKS. But of course, all the principles, all the things that I will explain today apply to any Kubernetes installation, and will focus more on Istio, right? But so I'm gonna use AKS, but it could be any other cloud provider, or even do that on-prem. So something also interesting for you if you're interested to try to assess a bit your skills in some domains. I also recently created this website where you can come and self-assess yourself on some topics. And if you don't want to play the game, let's say, there is also just an indication mode where you can basically have explanations on some answers and some rationale on why you do things that way rather than that way. Right, so feel free to come, it's free anyway. So that said, let's come back to our topic. So why are service meshes on the verge of becoming the new norm? So I would say in a nutshell, but that's my observation. I have no figures to prove this, to demonstrate this, but I think that the rise of service meshes is linked to the rise of microservice architectures. And of course, service meshes and let's say Kubernetes, right, are often of course used together, are a very good infrastructure to accommodate, let's say, microservices. And not only this, but that's particularly useful. So, but what are microservices? I'm not going to enter into the debate because actually you can ask 10 persons its opinion about, or their opinion, sorry, about microservices, and it will probably come back with different stuff, right? So I think that some will consider that you have to use microservices together with domain-driven design in the DDD. Some services just consider that, so some folks will consider that microservices are small services. For me, that's not a good explanation, but of course, usually microservices are not huge. Some will say, okay, that you don't do microservices if each microservice doesn't have its own data store, right? Because then you have full autonomy and so on. But in the real world, you also see a lot of let's say, microservices architectures where they still share some data stores, right? So some will say, okay, you have to prohibit the use of synchronous connectivity, so direct communication from one microservice to another, and only use asynchronous communication, right? So to publish your events, your basically data changes, and let others pick up what they're interested in and update their own store, for instance, right? And then doing this only, you don't need to have synchronous calls anymore. But the reality tends to be more complicated than this. So I will not enter the debates yet. You should only use asynchronous and so on. I will actually rather, I think that we can all agree on the fact that microservice architectures are distributed, right? So these are distributed applications. I think that's the key takeaway, I think, of microservices. However, or to which extent you apply them, and even if you end up with actually a distributed monolith instead of a true microservice architecture, still it's gonna be distributed in the end, and you will be able to leverage some of the expected benefits, right? Which actually are typically an increased business agility, right? That's why you would go to a microservice architecture. That's one of the benefits, more autonomy, more flexibility for the business. And so, for instance, with that, I try to couple a bit what service meshes can bring you in terms of the expected benefit on the one hand, and what service mesh can help on the other hand, right? So and in, for instance, a service mesh like Istio can help you to do blue-green deployment, A/B, canary, so basically to use feature flags, something similar to feature flags, and make sure that you have a better agility as well, right? So that's one advantage of service meshes, that bring stuff on top of your Kubernetes architecture, right? Or infrastructure. So, of course, in terms of scalability, well, we have the smart load balancing. I will show an example with gRPC, but it's of course not restricted or limited to gRPC. It's just that service meshes usually will really understand application layer 7 protocols, or issue application related protocols, and will have smart load balancing, let's say, strategies to make sure that they accommodate those protocols, and that basically they will also leverage the full power, the full scale out story of cloud native workloads. And that we'll see a concrete demo about this. And then, of course, they also help improve the resilience of, let's say, your applications, because often they come with circuit breakers, retries, fault injection, to do a bit some chaos engineering, and just make sure that your application is actually, or your applications are robust enough and can sustain, let's say, some storms, right? So they come with all of that. Not only this, right? They also help tackling, let's say, the typical challenges that you have with, let's say, the distributed applications in general. So whether you call them microservices or not. So first, it can be chatty. So again, here smart load balancing can help in either optimizing this, not really reducing, but optimizing this. gRPC is an example, and I'll show that. It's also about helping to tackle the non-functional requirements and be a bit more consistent, right? So the advantage of a service mesh is that you can offload to the mesh some cross-cutting concerns and some non-functional requirements, just to make sure that not every developer or every developer team, right, in charge of writing one microservice, for instance, ends up doing its own stuff for the non-functional stuff. I know that we want to have an increased agility, want to make sure that each team is empowered. Let's say each product team will actually be empowered to work a bit as they intend. But let's face it, in the enterprise world, let's say, especially with big corporations, it's almost impossible. I mean, you have also to bring some consistency. And the good news is that with a service mesh, you can have both. You can still give full freedom to developers on how, I mean, they develop pure business-related code, but you should try to enforce, as an architect at least, try to enforce some consistency, and service meshes are a way to achieve this. So, for instance, security concerns, things like load balancing and so on, but security is one of an important NFRs as well, scalability and so on. So, and also something that, that's a downside of, let's say, of using heavily distributed applications, is that at some point you might lose track a little bit on who is talking to who, how are they talking together, right? So you lose a bit the track of this thing, and then service meshes in general come with an increased observability, so where you can really see, the full flow of, let's say, a call, right? So we have an initial request, and then it goes there and there and there. So this is something that can be also tackled with service meshes. So that's quite important features, in my opinion. Okay, folks, let's have a look at smart load balancing with an example on, let's say, using gRPC. So, before we jump into the demo, let me first see the code of the deployment. But the purpose is to show you how, let's say, plain Kubernetes load balancers work with gRPC. It's an example, and then what Istio, a service mesh, then can bring into the mix. And so, by design, gRPC is actually one of the advantages of using gRPC over plain HTTP, especially HTTP 1, is the fact that gRPC will leverage the same TCP connections once it's established between the client and the server. So you don't have the overhead of creating the new TCP connection for every request. So it's of course faster. Other of course benefits are streaming capabilities and that kind of stuff. And so what I want to show here very concretely is an example with, let's say, a gRPC service that I developed and a gRPC client that I developed, right? And so basically those two guys, so what the client is going to do is going to call, in this case, every 5 seconds, it's going to call my service, and the service will return its instance identifier, right? So because then you know, the client knows to which, let's say, service it got redirected by Kubernetes. So basically, that's, let's say, the plain demo that I want to show you here. So I'm going to deploy this guy. So I'm already in this, let's say, right folder. So I'm going to deploy this guy, and with the apply command, and I'm going to take first the non-Istio one, and then I'm going to deploy this in my gRPC namespace. And what I'm going to show you here is basically, or let's have a look at the pods. And you see that it's already up and running, one-on-one, so no sidecar injected in this case. And if I log this guy, so kubectl logs, and I'm taking this guy, and then I'm gonna say gRPC, then you will see that indeed I've got, let's say, well, this exception is normal. Let's say it's because the client tried to call the service before the service got ready. So I code the exception in the code, and I just spit it out here in the logs, right? But here you see that I receive an answer from the server, which is basically the instance identifier I was referring to. So if I go here, so every 5 seconds, now it's gonna receive this. So to make things a bit more funny, I'm gonna basically add an autoscaler to my gRPC service, and basically I will first add it and then explain the goal. So this guy here, oh, okay, this was already there, so I forgot to remove it. Doesn't matter, so that's good actually. I will show it. Well, it's not the first time I run this demo, so that's why. So let's see gRPC. So I've got this guy here, and you see, so it's already over target, so it should already actually scale out my service. So let's list the pods, right? So right now, yeah, I still have one. So what I'll do is hammer basically the calls, right? So here, instead of having one call every 5 seconds, I'm gonna increase, let's say, the frequency, and I'm gonna say that I'm gonna basically do that every 50 milliseconds. So I'm going to reapply this guy here for the change to take effect. So if I now list my pod again, so the previous one is going to be terminated and the new one will start, you see. So it's terminating. So this one is already up and running. So let's log this guy to see a bit. Oops, sorry. So that was hit the enter key. So let's have a look. So now I have much more, let's say, logs, of course, because it's doing that every 50 milliseconds. And you see, so still the same instance identifier. So now my HPA, which we had a look at before, should actually detect. So it's still a bit stuck at 16% now, but it should actually at some point kick off and increase even more. So it should do, let's say, it should multiply the number of instances of my gRPC service. So let's see, we have to wait a bit. I could do that manually as well, of course, but I wanted to show you how plain Kubernetes works out of the box. So let's see, that should at some point be taken by Kubernetes. So gRPC still 16, normally should already scale out actually, because the current usage is beyond the target. But let's see, so okay, you see now it picked up the new metrics, so 44%, so it should actually kind of at some point, yeah, now it has multiplied my gRPC services instances. But if I log this guy again, you will see that it's still, you know, only hitting one single instance, because I still have only one instance in this case, right? In fact, I have 3 instances, sorry, but because of the behavior of gRPC, it's still talking to the same one. So that's a bit the downside of, let's say, TCP layer 4 load balancers, like the Kubernetes ones, is that they don't understand the application layer protocol, so layer 7, and then, of course, they just keep sending that, so this guy is not aware that there are 3 other instances, and it's not interfering with the behavior of the client, right? So let's now delete actually this YAML file, and then let's try to see with let's say Istio, by adding Istio to the mix. So let me see this guy here. So I'm gonna now add my let's say the Istio one, right? So it's the same demo, but now with Istio to the mix. So minus F, and then it's gonna be Istio, and then the namespace is gonna be gRPC Istio. So you could see clearly that without Istio, at least the only a single instance kept being consumed by the client, and so you did not leverage the power of scaling out the pods basically. So let's now see. I should also have some pods now in my Istio namespace, gRPC Istio. Let's have a look. So 212, because now this time the Istio sidecar has been injected as well. So same here. If I log this guy, I should receive basically more, also same kind of output than I had before. So let's have a look. So, and you see here that indeed, so also an error like the first time, doesn't matter, still okay, same instance, still on 5-second rate, right? So that's a bit what it's doing, so same as before. Now, let me see, I think that I still then had an HPA as well, else I'll just create it. So yeah, it's there, right? So it's already as well over target. So I will basically, but that comes from a different test before, so it doesn't matter too much. And I also put ridiculously low resource requests, you see. So if we come back to the deployment, you see that this is basically what I asked, so it's very, very low. So to actually make sure that my pods would scale out, right? So that my deployments would scale out. So let me then now still edit the Istio one as well, and say that we're gonna say every 50 milliseconds as well. So I'm going to reapply this guy. Reapply this guy. And then let's have a look at the pods. It should again start up and stop the other ones. Okay, terminating. Yeah, the thing is, it was already scaling out. Okay, that's a kind of a funny situation here. It was already scaling out my previous services. So let's see, terminating. Okay, so now still I have then two services right now. Okay, so it's anyway, I should have then no more than a single instance identifier. So let's log, let's say the client logs. Okay, that's another one. Yeah, I redeployed the CLI as well, so that's why. So let's see, I'm gonna take this guy, and then you see here that indeed I've got, let's say, my two instances right now, which are indeed, so Istio has interfered with the load balancing and make sure that all my instances are being used, right, by the client, so that we have an even distribution of the workload across services. In the previous demo, we had only one single instance use, right? 3 started, but 1 use. And that's the kind of things where Istio can add something to the mix. Of course, in the real world, if you have more clients, then the more clients will also, let's say, you consume the other services. But once the connection is established, then it kept sending its traffic there until potentially the service instance crashes, because it would be too overloaded. Right, so that's where Istio can help. If I now look again at my pod, maybe I have even more. You see, so I have 3 instances now. So if I log again, I should at some point find 3 different, and you see that's really evenly distributed now. You see, so that's what I call smart load balancing. So, okay, so let's see what will be for our next demo. But that was a nice one on the load balancing. Okay, let's have a look at a microservices sample app that I have developed as well. So before diving into the demo, let's have a look at the big picture of that app. Very simple. So that's, let's say, a demo I did for something else as well. But anyway, so we have 3 services: an order processing service, a shipping service, and another query service. They communicate with each other in an asynchronous manner. So today I'm gonna only show this scenario. So, and they also communicate directly. I mean, the shipping service, for instance, can call the other query service just to make sure that the order is, or grab some extra order details before starting the shipping really, and make sure that the order still exists, right? So we are in a choreography based scenario in this case, so there is no orchestrator. And then there are some other channels, so like an APIM channel, but in this case I'm not going to show that today. And here the service bus is actually a RabbitMQ that I put, let's say, inside the cluster. And I'm not gonna show the event hub integration, but anyway, it doesn't matter. So you see in this scenario, we have then three services talking to each other in either asynchronous manner or synchronous manner. And they also use Dapper because that was, let's say, something that I used for that demo. But on top of it, now I used Istio. But I found it interesting to talk about it as well in this, let's say, talk, because basically you will not find too much Dapper and Istio working together, right? Too much information about this. And actually, it's a bit challenging. So I raised a few issues on the Dapper side. I'm not sure if it got fixed in the meantime, but it was kind of hard to get them work together in a nice way. But in the end, it worked. But what is important is that Dapper also has some service mesh capabilities. It's not positioned as a service mesh, let's say, product, but it has some overlapping feature with, for instance, a true service mesh like Istio, in terms of MTLS, for instance, and that kind of stuff, right? So today I'm gonna first, we're gonna see a bit this in action, and then I'm gonna add something that Istio can do for you, which you can also do with Dapper, by the way. But since the topic today is a true service mesh, I'm gonna show that with Istio. So that's for the big picture. So let's get started. So I have my microservice up here. So let me basically, well, I have deployed it already. So let me show you the deployment so that you see a bit what it looks like. So I've got basically my shipping processing, well, service accounts. And so that's my service accounts. And then I have like my RabbitMQ. And then I have like my order processing service that we discussed about, my order query service, and my, let's say, shipping processing service, right? Or shipping service, sorry, yeah. And so you see it's Dapper enabled, basically. And I have also, let's say, enabled Istio with a few stuff, few restrictions to the Istio proxy, but I will not enter into those details today. And my namespace is injected with Istio, right? So that's why it's not here explicitly annotated. But anyway, so it's already deployed. So if I list my pod here to my, let's say, get pods of the microservice apps, then you see that I've got then three, at least for the non-RabbitMQ, I've got three containers. So the let's say the one that contains a business logic, so my application, the Dapper one, and the Istio one. So it's actually two sidecars and one real container, let's say, containing my code. So let's maybe see this in action. So I have also exposed, let's say, one of the services outside of the mesh, so I could call for demo purposes it's easier. So I will actually start Fiddler, and I will basically make an HTTP request to queue an order. So let's me have a look at this. So if I make an HTTP post query, let me see, I have a cheat sheet here just to make sure that I can basically query this guy. So this is the order processing. So I thought I had saved the full path, but it's not the case, it seems. It doesn't matter. So let me see. So I'm gonna say, I'm gonna call or invoke, let's say, this service from outside. So it's gonna be this guy. So microservice dot silverite microservices.silverite.com, and then I'm going to invoke this guy. I'm going to simply put define content type. So it's going to be application JSON. It's a new machine, so I did not have time yet to reinstall Postman and so on. And let me just grab this. This will be the my let's say products. I'm gonna send to products. Right. So let's say it could be whatever. In this case, it's just a fake product. I'll just change the GUID to have a different here. So if I send this guy, so I'm warned because my certificate is invalid, it doesn't matter. So yeah, I forgot to copy one part of the URL, sorry for this. So v1.0, that's the one I need to add before the invoke. .0, that's a Dapper convention. So here, well, I got the 200, should have had the 201 by the way, but it doesn't matter, so the order should be created. So if I log now, grab the logs of this guy, so kubectl logs, and then I'm taking this guy, I'm gonna specify the order processing container, and then this is my microservice app namespace. Then you see that I've got indeed an order that got created here, right? So if I, let's say, do a few, let's see, just to make sure, I should have more lines in my logs to say that it's created. So you see it's not fake, it's really there. So if I now see, well, remember the diagram, so we have the order processing service, and then I have the shipping processing service. So let's take the logs of this guy, just to see if shipping could be done as well. So let's see, shipping processing. Well, you see, so starting shipping process, so it seems that this is okay, right? And then I can even look at the last one. So these, the order service and the shipping service communicated through asynchronously, basically through RabbitMQ. And I have then the order query service that can be called directly by the shipping service because of, let's say, because the shipping needs some extra details, right? So let's see here my query service. So list my pods first. So I have this guy here. And then let's lock this guy now, order query. So it's going to be this one. Yeah, it's a little bit of, let's say, of manual work here, typing work, but yeah, order query. So that should be it. And you see here indeed checking for order. Everything works fine. So in this case, you could say, okay, why using Istio in this case? Because Istio is not adding anything to the mix. Dapper does the whole job. So, but the why is, of course, if you use Istio, let's say in general, as a true service mesh, then I think you should, even if there's overlapping features with Dapper, then you should still use Istio for service meshes, pure service meshes capabilities, so that you have, let's say, you have something consistent, even with applications that do not use Dapper. But anyway, so what could I add to the mix? Because here, okay, it's all fine. Load balancing will also be a smart load balancing if I use gRPC, which is the case with Dapper. So that's great. We've seen how smart load balancing can let's say, help. But we can do more than this. And for instance, in the microservice scenario, if we come back to the diagram for a second, we see that, okay, our intention is that this order query service can only be called by the shipping service. So we can actually enforce this using Istio, and so not especially doing that in code, right? Because I'm always advocating, let's say, to build stuff on top of frameworks and, let's say, robust stuff, then instead of reinventing the wheel, let's say, in code. So here if I just say, okay, I'm gonna end the show, but it was to come back on this, so I can enforce this behavior, right? So if, for instance, I take let's say, I think this is this one. So let me first check if it's not already enforced in my namespace. I'm going to basically put an authorization policy and say that's basically an Istio resource type, right? And I'm gonna say that I allow, let's say, for the order query service, that the only principles that is allowed to call is the let's say, shipping processing, right? So remember, in my deployment, I have my service accounts, I have my deployments, and then this guy here is actually the service account being used by my shipping service. So I can enforce this. So let me first see if I have already deployed it or not, so that I want to show it with and without. So get authorization policy minus n, that was the microservice app. So it's not there, right? So meaning that now if I want to basically call the order query service, and I'll come back to my cheat sheet here, I should be able to basically call it, right? To invoke it from directly from, let's say, this URL. So let's say here it's just here blank. So I'll just remove this to make Fiddler happy. So if I do this, I have indeed an answer, right? So here I'm directly calling the service from an unintended, let's say, place, because I'm using that from even outside the mesh, right? But that's for demo purposes, of course. But so now if I want to make sure that this does not happen anymore, I can simply come by here and basically apply it, right? So I'll just copy the path of this guy. And I'm gonna say a kubectl apply minus f, gonna be this one, and then the microservice app. Right, so let's see. So it's created, so it should be picked up almost immediately. So let's see if I can still do it. And sure enough, I have a 403 now. Right, so Istio has intercepted the request, sees that I'm not providing or not calling from, let's say, I'm not authenticating with the service principal that has been basically enforced, right? So that's working fine. And if I try now still to see if that still works fine for my, let's say, when I place a new order, then I can simply do, and what is interesting to show you maybe is, of course, the Istio logs. So if I list my pods again, get pods, if I look at this, then the order query service, which was the target of my query. So of course, for this guy, nothing happened, right? So if I logs here, if I take the logs of this guy, I have to specify the name of the container, sorry, order query. Well, it's not allowed. That is actually surrounded by Istio. Is not aware. Sorry, that is surrounded by Istio, and basically doesn't know that this call was not allowed. Right? For him, everything goes well as usual. But if I take the Istio proxy, right? So here you see we have three containers, and you see. So that's the name of the Istio proxy. So if I take this guy here, and I basically specify Istio proxy, then I should have something. Sorry, I probably did something wrong here. I think I just did not copy it correctly. Istio proxy. Then I should see at some point that, okay, it had access denied, you see? So that's basically Istio proxy that code this internal call, Dapper to Dapper sidecar, and said, hey, guy, by the way, you are not calling from with the proper identity, right? So now if I then look at if my previous scenario still works, if I now place an order again, right? So or maybe a few even. So okay, I'm still having, everything is working fine here, but remember my order processing service is independent from the rest. So it could say, yeah, that's okay, I received the order, but maybe later in the chain there would be an issue, right? So in here, let's look at the logs of the order query. So you see here, oh, not the issue, sorry, the order query one, because that's the end of the chain. So if I have something here, then I'm sure that everything, the whole transaction was basically done, right? So, and yeah, I should have put the timestamp anyway. Maybe there are too much information here. So let me log the shipping service, because I think that's basically, there are less entries. Yeah, still quite a few, but you see, so we have like yeah, like 30 entries. So let me actually really do something a bit more visible. So I'm going to replay this guy, let's say 100 times, so that my log should grow quite significantly. All right, so you see here we have this, so it should basically be okay, and we should have much more lines, right? And you see that anyway, I don't have any issue here. So it started the shipping process, let's say, for these new orders, right? So here it still works as before, but now I have enforced the fact that only the shipping service can call the order query service, and that is done with Istio instead of relying on custom code to do such things, right? So that's so by default, when you enable MTLS, every service that's part of the mesh will anyway have to, let's say, present a certificate that will be trusted by let's say, the target of the call. But you can go further than this and refine, have fine-grained permissions for service-to-service communication. So that's also one benefit of, let's say, service meshes. Okay, folks, for this last demo, I'm gonna talk a little bit about different things. So authentication, authorization, throttling, so how to apply throttling policies, and probably other stuff as well. So to do this, I'm gonna rely on, let's say, a sample app made available by Istio, by the Istio folks themselves. So it's called the Book Info application. So I basically installed that application and I added my own bits to the mix. But in a nutshell, it's a simple application that is designed to demo, let's say, some Istio features. And so that's the architecture of this application, where you have different versions of the review service, and you have a single product page, and then the product page will send users to either review v1, v2, v3, depending a bit on your profile. That's not what I'm going to show today. There is also a detailed, let's say, service that gives some information about the book itself, and then a rating service. So basically, it's also like microservice app, with then each service doing its, let's say, a limited set of features, functionalities, right? And they communicate with each other, in this case, all synchronously, right? So there is no like message bus, message broker, or something in between. So I'm gonna use this one. So I have already installed this application. So I would encourage you, if you look at Istio, to really play with it, because it's very let's say, it's well designed, let's say, and it's good to get started. So let me see now if I basically then, let's say, erase this guy here, and I'm gonna list my pods. Right, so I've installed this in the default namespace, and you see, so we have, let's say, the detail service, the product page, rate limiting, and review. So basically, that's a bit what we have. So that corresponds to the diagram that I've just shown you. So I'm going to port forward the port of this guy to my local host. Right, so here, so that I can browse to that page. So let me go here, browse to that page, refresh, and as you can see here, I've got, let's say, this very basic page. So they didn't really, focus on making something nice, but it's not really a problem for that demo, right? So, and we have then the details page and then the reviews page that are accessed by the product page service, right? Or product page itself, sorry. So that's a bit how let's say, the different services that we have together. So what I wanted to see or to show you a bit more is how to add some authentication and authorization to that mix, and also how to add an API gateway like features like rate limiting, right, throttling. This is typically something you do with an API management solution, but actually Istio ships with some of these features, so it's definitely not an API management solution, but it has some API gateway-like features, right? Throttling is one of them, GWT validation is another one of them. So that's what I want to show you, because that's also typical needs that you have in, let's say, APIs and microservice or API-driven solutions and microservice-driven solutions, right? To add these non-functional requirements to the mix without having to reinvent the wheel in code. So let me see. I will actually start with maybe the rate limiting. So I'm gonna show you. It's already active actually right now. So this is an Envoy filter. But you see that Envoy is an ecosystem solution, so it's not part of Istio, but here Istio has an Envoy module, let's say, so you can drive Envoy from Istio CRD, so custom resource definitions, and then define some stuff. So you have to install a bunch of services to have this guy work, which I will not go through because it could give you some headaches, but basically, once you have this set up, then you can have, let's say, you can start to put Envoy filter rules. And in this case, I just said, okay, I want to make sure that the detail service, which is actually the target of my workload selectors, right, is subject to rate limiting, that you cannot make more than 10 calls a minute. In a nutshell, that's a bit what you have here, right? And so let's see this in action to see if that works, right? So this guy is actually calling under the hood this this detail service. So I'm just refreshing. So if I basically now refresh quite a lot, at some point you see, so it tells me that, okay, the project details are currently unavailable for this book. So that's their app. So I didn't do anything code-wise, let's say. They just detected that all of a sudden they can't contact this detail service anymore. And that's because my throttling policy entered into play. So we can see that in a more clear way if I basically go to a busy box, right? So let me relist my pod. You see that I've got some busy box that I call. So it's just, let's say, plain tiny shell apps that you can exec to, so that you can have a shell and then start, let's say, talking to or doing whatever you want. So in this case, I'm going to exec into this busy box, right? And so, and here I'm gonna work or make an HTTP call to the same, let's say, to the same detail, but here using the internal name of the Kubernetes service to basically call this guy. So you see here I've got an answer, so like the author and so on. And again here, if I also then run it a few times, at some point gonna tell me that I'm limited. See, so that's a local rate limited. That's the effect of the throttling policy that you see. So that's something handy. So if you can't afford to have a true API management solution, like for instance Azure API management or other, let's say, vendors, Istio in this case can also offer you such features, right? So not to manage your APIs, but really more to add some security or some robustness on top of your services. Okay, so that was about rate limiting. So let's see something that's very used as well in when you use API gateways is JWT validation, right? Token validation. So here, with regards to Istio, you can actually have different resource definitions. One if actually is request authentication. So that's really to authenticate users and let Istio, let's say, enforce this authentication. And then you have and basically define what is the IDP, for instance, that will be in use. And then you have the authorization policy, which can be applied against, let's say, services. So in this case, I use my own tenant in Azure. So it's Azure AD, and I register an app in Azure AD with this, let's say, API identifier. And I just provide Istio with the keys, right? So to find where to download the keys, right, from the IDP, so that they can, because of course the tokens are signed with the, let's say, by the IDP. So that allows Istio to read and inspect the tokens. And then, of course, internally we have this this rule that will say, okay, on this method, in this case, just shows get for the demo, the key, the UPN, right, which is the name of the attribute inside of the claims, needs to be or contain this. So that's a very improbable rule, actually, because here I'm limiting the application to a single user, but just to show that you can, of course, filter out on claims, right? So let's see, this rule is not yet enforced. So let me see, just to make sure that it's not there. Okay, so it's not there. So meaning that today, or right now, and indeed, if you see here, okay, this product page is actually calling the detailed service, and I have no authentication in place, right? So what I'm going to do here is then I will apply this guy. So let's copy maybe the path, or copy the path, sorry, and then cd to that. Oh, you know what, even better, just apply the file directly. And so I will basically do this. And so now I should have then my request policy in place. And so if I refresh the page already, I should have at some point, take sometimes a bit of time, you see. So here it's not able to reach out to this detailed service because of course the policy kicked in, and I'm not authenticated, right? So it's expecting now to receive a token an access token that contains information that comply with the rule that I have defined. So to do this, what I actually did is, and of course, if I connect internally, let's say if I exec again my busy box, I will have the same issue, right? So let me try to, to find, where is it? It's here, the path. To find the path of my query, right? So of my service, sorry. So this is the service. So I'm gonna curl to that service. And so it should not actually work, right? I have an access denied. That's Istio returning me this because I've not provided any token. So in order to get that token easily, I basically quickly developed an MVC app that is allowing me to sign in, let's say, and to get such a token. So I will not go into the details of the code. It's using MSAL, so the Microsoft Authentication Library, to get tokens from for any, let's say, scenario, in this case, Azure AD. So let me then start this guy. So I'll be prompted to log in. And basically here, let's see, because actually I did not start this guy in private mode. So let me see, I will inspect the token. So what the app is doing is that it prompts me to log in, but if I've already logged in, it might just reuse the previous information, and it's spitting out the access token, right? So I'm gonna quickly inspect it because I'm not sure which account is being used to log in with this guy. So I'll just say online decode, and I'm gonna use my favorite site where you see that we have indeed this user. So that seems to be the right user, and then I have this API. And if you look, of course, inside the token, that's indeed this API that is expected here, right? So if I search for this guy, it should find it. Probably I have something. Oh, sorry, that's the token. Did not copy. Sorry, this guy for some reason copy. So now if I search for it, it's indeed in there, right? So this is the right audience in this case, a single audience, although it's an array because geo tokens can, of course, or access to tokens can contain multiple audiences, but in this case, it would contain the audience I'm exciting. So if I now take the token from, let's say, that I received with my sample app, if I add this token now to my call, right? Remember here, access denied. So I should then now be able to add this authorization token, right? So it's a bearer token, and then I already close this guy, add the token here. Then you see that I receive an answer. In this case, sorry, my token got, of course, validated by Istio, and then I'm allowed to go, let's say, further. So that's the kind of things that Istio can help you with. So again, so here it's the authentication authorization has been uploaded to Istio. So which doesn't mean that you can't also revalidate the token in the final backend service, but you might not be forced to do so, right? It also depends on your functional needs, if you really need to have the end user identity flying up to the backend service for some reason, else you can offload that to things like Istio. And again, ensure consistency between or across services in the way you check those things. So that's something that you can do easily with Istio. Maybe something else I told you would be kind of a mix. Let's say a mixed demo here. So we've seen the authentication bits. Let me see, authorization throttling we've seen. A piece of it, of course. Maybe I can also show you the exposure, right? So how you expose services outside of the mesh. And so that's through ingress rules. So if I take, I still have maybe an old folder here. So let me see. Because I did not move this to that resource. So let me see here a recent folder that I have where I should find this guy. So let's go here. And so let me close those guys. Okay, fine. And then go to a gateway or microservices dot silverit.com. So remember, I think I showed you that in the previous demo, in the microservices demo, but I could call and post my, I surely did. Let's say queue a new order by calling this guy, microservices.silverit.com. So I exposed let's say this my microservice app to the outside world through an ingress rule, and that is done with the gateway resource type or resource definition of Istio, where you can define some rules like which port number should it be let's say getting requests from, the protocol, so TLS, some information there, right? And the host, of course, the incoming host name from the consumer. Of course, I'm the owner of this domain, so I of course recorded a DNS entry to make sure that calls to this guy are redirected to my Istio ingress controller. And then as part of, let's say, this config, I also have a virtual service where I could have some traffic rules. In this case, I did not provide anything special, but here, of course, it tells me, okay, for this host, then make sure to, let's say, take a config of this gateway, and then it will basically say, okay, for slash, so which is basically then the host header HTTPS and then slash, it will basically then route to, it will not rewrite anything in this case, and it will, let's say, go to order processing Dapper, which is one of my hosts. And so I have rules like that, let's say, for order services as well. So that's also something that you can do. So the advantage of products like Istio is that you can, using the same product, you can basically tackle different things. So ingress, egress, security related concerns, so like MTLS, observability. So I don't have time to show you that today, but a lot of different things can be managed with the same service. So I think that's or the same product. That's kind of interesting stuff, right? So okay, that's it for the demos, guys. So I think that we're gonna go to the key takeaways of the session now. Okay, so let's see the key takeaways of this session. So we should use service meshes to increase performance and scalability. So we've seen that with the gRPC demo. That's just one example, but if you really want to leverage the built-in scale-out capabilities of Kubernetes, then you'd better, let's say, use that together with a service mesh that is smart enough to, let's say, understand layer 7, let's say, ways of working. So you should also use service meshes for microservices at scale. So here we could not really, I did not have time to go down that path and to show you what you gain in terms of observability, but just remember this. This is really something that helps you grow your microservices. Is actually this observability, so meaning the possibility to see the flows, to see the latencies, to see really to observe really the system, and when it scales, then you need even more such features, right? Of course, if you have only 3, 4, 5 services or even 20 services, it's still manageable. But if it scales up to hundreds of services, then definitely this observability stuff will be actually very handy. So you should as well use service meshes for traffic management. Here again, I've not shown much things there, but yeah, all the, again, that's non-functional, but ingress policy, rules, egress, so traffic, outbound traffic, traffic split, that I talked a little bit about in the deployment, so blue, green, and so on, that's kind of traffic split. Network policy, so who can talk to who from a network perspective. That's of course something that you can also rely on a service mesh. Often the service mesh itself is actually reusing other, let's say, open source projects or other ecosystem solutions, but you can drive them from the service mesh itself. And then, of course, you have like whenever you want to enhance the security, then you can, of course, count on service meshes for this, because you have MTLS out of the box. And so mutual authentication, we've seen an example where we really go to deeper, fine-grained permissions. But of course, this is also to guarantee some consistency across workloads, across applications that are being developed, that they basically adhere to the same rules. So that's maybe the biggest takeaway of this session today. So don't reinvent the wheel in code, just try to use service mesh capabilities for these kind of things, for cross-cutting concerns and let's say non-functional requirements in general. So with that, the session is over. So feel free, of course, to share it and speak about CloudGen, let's say with your friends and promote that on social networks. Thank you and see you next time.